Hello, good day. We are going to discuss about what is called the minimum spanning tree. Usually, we construct a minimum spanning tree for a graph. A graph is supposed to contain number of vertices, and each vertex is given a cost. We call it as a weight. And in the construction process, we have to remember certain things, like if there are n vertices in a graph, there will be n minus 1 edges will be present in the spanning tree. There may be a number of edges in the given graph, but the spanning tree will contain only n minus 1 edges. For a given graph, there may be more than one spanning tree, and for a given graph, there may be more than one minimum spanning tree. And the edges used in the construction of the spanning tree must be the edges of the graph. Very important thing is, while considering the minimum spanning tree, for example, this is a graph. There are number of configurations of the minimum of the spanning trees. This is one configuration. This is another way. This is another way, and this is another way. So totally, for this given graph, we have drawn 4 spanning trees. If there are, as I said, if there are 4 vertices, the vertices are 4. Therefore, in each of this spanning tree, you will find only 3 edges. So as I said, you will have n minus 1 edges. So there are number of algorithms for constructing a spanning tree. Of all, one is the Kruskal's algorithm, and the other one is the Prim's algorithm. So let us see the Kruskal's algorithm of constructing a minimum spanning tree. So constructing a minimum spanning tree using Kruskal's algorithm. So the process consists of, first of all, arranging the edges of the graph in a non-decreasing order, and then we start constructing the minimum spanning tree by taking one edge at a time in the from the order which is arranged and dropping the edges that form a cycle. We continue this addition of edges till there are n minus 1 edges in the tree. Now let us take an example and then discuss. Now let us take that this is a graph for which we are going to develop a minimum spanning tree, and the graph has a number of edges, number of vertices. So there are 7 vertices in this. So there will be 7 vertices. It means in our spanning tree, you are supposed to contain only 6 edges. Okay, but for the edges of the graph, as I listed here, BD, AB, AC, BC, CD, CE, DE, DG, BF, and EG, they are all the edges of the graph. I have arranged these edges in the non-decreasing order, or you can say the increasing order, but appropriate word is using the non-decreasing order. Now, you consider the edge BD, because it is the smallest, and construct an edge between the vertices B and D. Then the next edge you are supposed to take is AB, because in the order it is there. So to construct the edge AB, this is the second one. Now the number of edges constructed till now are 2. Then the next edge you are supposed to consider is the AC, and you see I have considered this AC, and also I have added this edge. So the number of edges added till now are 3. Then the next edge which I am supposed to take is BC, because it is in the order. Now, but if I add BC, if I take this BC, it is forming a cycle. AB, AC and BC, it is forming a cycle. Therefore, I will not consider the edge BC. Now, coming to the next edge. In the order it is CD. So if I add this edge CD, again it is forming a cycle with the ABCD. Therefore I also drop the edge CD. Next, as per the order, I take the edge CE. So the edge CE, I'll add it. The number of edges added till now are 4. And then again, the next edge in the order, as I said, DE. So you cannot take DE, because if you take this edge, it will form a cycle. Therefore, this edge is dropped. We are not going to consider this. Now take the edge DG. In the order you will find DG. DG is there, the next one. So then the number of edges added till now is 5. Then take the next one in the order, it is BF. So and then you construct it. The number of edges added till now are 6. So as we said, the number of vertices are 7. Therefore, the number of edges you are going to have in this is 6. Now, if you add up all these edges which have been considered, it is 1 plus 2 plus 2 and 3 plus 4 plus 4, it is coming to 16. Hence, you say that minimum spanning tree is constructed. But one thing you have to keep in mind, that for a given graph, there can be more than one minimum spanning tree. There is no doubt about it. For example, here you have considered this AC, and when it was a question of BC, you have dropped because it is forming a cycle. If you would have taken BC first, then certainly you are going to drop AC. So the order is important. But anyhow, it is going to construct a minimum spanning tree using this particular approach. So this is very easy and very comfortably it can be executed. Thank you.